Good morning. Welcome. I'm here with the Pueblo Department of Public Health and Environment, and my name is Libby Stout. I am an addiction psychiatrist, and I'm giving a presentation on the science of addiction. And my hope is that people that are thinking about using an addictive substance will hold off on that. So this is very much, geared toward kind of prevention efforts. But I also hope that people that are experiencing a problem with addiction right now will have a better understanding, or their family members will have a better understanding of what's happening and what you can do about it. All right, so let me see if I can get started here. I'm going to share my screen and get my slides up here. Okay, I think we found it. This is the first time we've done this, so this is new technology. All right. So I want to kind of explain in terms that hopefully everybody can understand. Why do some people get addicted to substances and why it can be very difficult to quit for some people? If you think about why people use for the very first time, there are many reasons why people choose to use an addictive substance. And often it's in adolescence and it's due to curiosity. It could be curiosity in adults too, but very often it's because parents, family members are using the same product. And then there's also peer pressure. But a big one also is advertising. And we are all susceptible to advertising. And so many ad campaigns have been eliminated because of this. I mean, if you look at the one with the doctors smoke Camels, that was back in the 1950s. And that's when the tobacco industry was under pressure because there was evidence that smoking tobacco caused cancer. And tobacco industry didn't want people to not smoke because they didn't want people to believe that. So they got doctors to advertise to smoke Camels because it was the best cigarette to smoke. Once somebody starts using, why do they continue to use? And often you think about it, the first time somebody uses isn't always the best experience, but people continue to use anyway. And because it works, it does something immediate. It can numb pain, both physical and emotional pain. It can help people cope with trauma and abuse. It can disinhibit people, so then they feel they're much more likely to be social, gives energy. There's this kind of temporary sense of well-being. But the problem is these drugs can actually hijack your brain because they work in the same part of your brain where we learn to do everything. So this is the learning and memory part of your brain. And once the drugs hijack this part of the brain, the use is no longer a choice. So this is the reward pathway. This is the learning and memory part of the brain. And everything you learn to do that's important happens in this pathway. So you get this release of dopamine in the nucleus accumbens, which is deep down inside of your brain, and this promotes learning. We have this pathway on purpose because it helps us remember to do things like eat. So this is a natural reward pathway. If you remember the first time you had a nice juicy hamburger, you got to release a dopamine in the nucleus accumbens that said, that was really good, we should do this again. You do it again, you do it over and over again, it gets hardwired into your brain and you don't ever forget. So the next time you think about it, you think about a nice juicy hamburger, you may be thinking about it right now, you start salivating, you get hungry, and you eat it. This is also for natural rewards. So this is a pathway used to help us feel good. So do you remember the very first time you learned to ride a bike? Do you remember how great you felt when you succeeded? So do you realize now that it's learned, it's hardwired into your brain, it's never leaving, and you don't ever forget how to ride a bike. Even if you don't ride a bike for years, if you get on a bike, your brain says, I know how to do this, and you ride away. So this is just kind of an explanation of the brain. So this is the brain working. There's actually a difference between the brain and the mind. So the brain is the physical structure, And I want you to imagine that this is a 2-year-old about to touch a hot stove. And the mother is yelling at it, don't touch it, it's gonna hurt, it's gonna hurt. But the 2-year-old touches it anyway. Well, what happens, there are C fibers in your finger, those are pain fibers, that send a message up to your spinal cord, up to your sensory cortex of your brain, and then send a message to the motor cortex of your brain that goes back down through your spinal cord, out to your finger, and you pull your finger away. And that happens within a fraction of a second. That's very quick. Your brain is saying, oh my God, that hurt. And you pull your finger away. However, at the same time, your mind is working. So your mind is processing all of this information. And the mind is the energy that flows between the different parts of your brain. And so what happens here is you have this pain pathway coming up from your finger. But at the same time, your reward pathway is sending out some dopamine saying, this is important, we need to learn and remember this. You have the memory, which is the green part, that's your hippocampus, that's where you put your new memory and learning. And so the auditory cortex is hearing his mother's voice, the sensory cortex feels the pain, the motor cortex feels the movement, and so all of that is getting processed. The problem with 2-year-olds is that purple part, the seat of judgment, which is the prefrontal motor cortex, it's not working yet. And so that's why you have to tell a 2-year-old multiple times not to touch the stove. But you know this is working as in terms of learning and memory, because the next time the child is about to touch the hot stove, the mother, all she has to do is go, ah, and the kid pulls his finger away, like going, oh yeah, I remember, that hurts. So you have over 100 billion neurons in your brain, and every time you learn something new, a certain number of neurons are wired together because there's over 10,000 connections. But you don't use all of your neurons when you're learning something, you just use a few of them, and they get wired together. And then they fire together, and that's why it happens over and over and over again. But if you look at the effect of addictive drugs, if you think back to food, food was a 1.5-fold increase in dopamine. Nicotine is more powerful than food, so it's a 2.5-fold increase in dopamine. The opiates are similar, and that slide just shows you, so morphine shows you that the higher dose, the more potent the dose, the more release of dopamine. Then in the upper right is cocaine. That's a 4-fold increase in dopamine. And amphetamine or methamphetamine is an 11-fold increase in dopamine. That's why that drug is so powerfully reinforcing. Somebody does that one time and they're like, whoo, boy, that was important. We need to do that again. And so this is called salience. The dopamine says to your brain, this is important. Not everybody who uses a drug becomes addicted. In fact, for alcohol, we know that at some point in time, almost 90% of the population has consumed alcohol at some point. However, not everybody becomes addicted to it. And so most studies say that like 15% of people that use alcohol can become addicted to it. The other drugs have higher addiction potential. The one that causes the most addiction is tobacco or nicotine. And this is really because it's the only drug people smoke all day long every day. But if people are smoking anything else all day long every day, then they also become highly addicted to it. So one of the things that we have found about using drugs is the effect on dopamine. Now, as I said, dopamine is the salient factor. It gets released when you use the drug for the first time. However, if you use it over and over again, you start depleting your own natural stores of dopamine. Now, the important thing to look at in this picture are the red. Everything else is just don't pay attention to. It's the red in the middle of the yellow. The red are the nucleus accumbens dopamine receptors. And so if you look on the left-hand side, those are control people who have not used those substances addictively, and they have a lot of red. The other side, on the right-hand side, are the people that use cocaine addictively, alcohol addictively, or heroin addictively, and they have almost no red. So they have depleted their own natural stores of dopamine. This happens on all types of addiction, even behavioral addiction. So if you notice on the far left, this is smokers. Tobacco does this. Well, it's basically nicotine does this. Nicotine depletes people's brains of dopamine. Alcohol does. Overeating, excessive like binge eating can cause this, and cocaine. So it's true for all addictions. And this is kind of the pathway people start seeing. If you look at it, we have these normal mood swings, normal ups and downs. We have normal things. So when we do natural highs, we feel pretty good, and then we may feel not so good, but it's a normal mood swing. You use drugs and you get this huge amount of dopamine that you say, I felt great. But then there's this drop, significant drop, where you have to come back to using drugs to just feel normal. And then people use over time, you're depleting your dopamine. You don't even feel normal anymore, but you feel like you have to keep using drugs. Recovery is totally possible, and that is a great message. And this is just showing that on the far left is a human brain, a healthy control who's never used methamphetamine. They have a lot of red, so a lot of dopamine. The middle one is somebody who's been abusing meth, but has been abstinent for 1 month. They have almost no red. That's because methamphetamine is a really bad drug in terms of destroying dopamine transporters in the brain. However, that same person, 14 months later, still not using meth, their red is back. So this is a very good message that recovery is totally possible. You just have to stop using the drug. So your dopamine, your natural dopamine, can resume. Meth takes a long time. Some drugs are more forgiving, and it takes less time for you to feel better. This is more explanation about this pathway and the different parts of the brain that are working. And so I'm just going to give you a little kind of scenario so you can follow this. So say I used cocaine for the first time in my life. I've never tried it, but say I did. I would get a release of dopamine in the nucleus accumbens, which is right here. And that would then send a message to all the rest of parts of my brain via glutamate, which is a major neuroexcitatory chemical in your brain. So it sends a message via glutamate to the amygdala, which is right here, which is your warning system. And it would say, boy, next time you see that guy that gave us that substance, warn us. And then sends a message via glutamate to the hippocampus, which is here, which is where you put all of your new memory and learning. Would say, next time the amygdala sees that guy, remember what he's good for. And then sends a message via glutamate to this green part, the orbital frontal cortex, which is your motivational drive part of your brain, saying, next time the amygdala sees that guy, warn us, go get him because he's got some good stuff. You just have to do that a couple times and it gets hardwired into your brain. The problem is if you do this during adolescence, this part of your brain, the prefrontal motor cortex, the inhibitory control, where you make good decisions, you make judgments, isn't working very well. This is the last part of your brain to develop during your brain growth. It's not fully developed until late adolescence, early adulthood. Most people put this at mid-20s. And so that part of the brain isn't working to say, oh no, maybe that's not such a good idea. So this gets wired into your brain and it's hardwired in there and it's never leaving. It will always be there. This is why somebody can sit in jail for 6 months, not using anything, and thinking that, yes, well, maybe I won't do anything anymore. but they're not doing anything to change their thinking. They get out of jail and the very first thing they do is go buy a pack of cigarettes. Then they might go to the bar and get a drink, and then they might see their drug dealer and make a buy, because they haven't done anything to wire some of those other 100 billion neurons to make new pathways in the brain. Now, this is actually something we can measure, because you can measure glutamate receptor ratios. Now, we don't measure that in humans, but we do measure that in animals. So you can do this with mice. And what they show here is, this is on the y-axis is the glutamate receptor ratio. So this is just showing whether people are learning or not. And this has actually been termed long-term potentiation. And what that means is, when somebody has long-term potentiation, that means you get a dopamine release the first time you use, then you get an even more powerful dopamine release the second time you use because of increased glutamate delivery, and then that really reinforces the learning. So this here, saline is salt water, so that's the control. That's the normal ratio of glutamate receptors in the brain of the mice. If they give them cocaine, amphetamine, morphine, nicotine, alcohol, it's basically all the same. All the addictive chemicals do the same thing. They cause long-term potentiation. Drugs that are not abused, and these are psychiatric drugs like fluoxetine is Prozac, carbamazepine is Tegretol, used for bipolar disorder. They do not cause long-term potentiation. That's why people have difficulty remembering to take their psych meds, because they don't get a dopamine release from taking Prozac. So it doesn't say, oh yeah, that was important, I should remember that. The other thing that causes long-term potentiation, and more than anything, is stress or trauma. And that is a very good explanation of why people who have been exposed to bad things happening to them in childhood, like trauma, abuse, neglect, they can have long-term potentiation from just that. And that means they already have increased dopamine production. And so the first time they use a drug, they get an even more powerful dopamine release, which can result in people having problems with addiction because of the trauma. And then finally, the other part of the brain where this very much affects is your ability to learn in the hippocampus. So the hippocampus is a part of the brain where we actually have now discovered you have neurogenesis. What that means is new cells are being born and differentiating in your hippocampus all the time. However, if you use any addictive substance chronically, it's been shown to decrease neurogenesis in the hippocampus, and imaging actually shows that it shrinks the hippocampus. So that makes it very difficult to learn new things. And this is true for all addictive drugs, including nicotine and THC from marijuana. We can test this in animals too. So this is a really great study, a way of testing to whether an animal can learn. And you can do this with rats or mice. And this is called a Morris water tank test. So there's this very big vat of water in the middle of the room. And under the surface somewhere is a block of wood. And what you do is you put the animal in the vat and you calculate how long does it take to get to that block of wood. So it just bumps into it and it can get on it and say, oh good, I'm not going to drown now. So you know that's a smart animal because you have pictures all around the room, and that animal can actually triangulate where that block of wood is by looking at the pictures. So then the next time you put them in the vat, they go right to the block of wood. And you go, boy, that's a really smart animal. Now what they've done is they've done this with all drugs. You can drug up the animal and they cannot find that block of wood to save their life. They have to keep swimming around until they just bump into it. And that's because they don't have neurogenesis in their hippocampus and they're not learning new things. But the good thing is recovery is totally possible, because what they do is they stop the drugs and then encourage them to exercise. and they find that within a short period of time, they are able to find the block of wood. So your hippocampus can recover. You just have to stop the drugs. And the very best treatment is exercise, because that's one of the things that we have discovered that improves neurogenesis in the hippocampus. So even just walking every day is a very good thing to do. One thing that can set up people for addiction is this thing of being exposed, either in utero, so when the mother's pregnant, or during childhood, or during adolescence. If somebody is exposed passively by smoke, the smoke is in the drug is in the smoke. And so it's in your brain, whether you're smoking it or not. And this can start the process. So this can actually prime the brain. And we've studied this mostly in animals. This is just showing that if you give an adolescent rat nicotine, they're much more likely to press the lever for nicotine as adults than if you gave them the nicotine as an adult. And this totally correlates with research that we know about tobacco. What we know is if you start smoking before the age of 19, you're much more likely to become addicted and have difficulty quitting smoking than if you start after the age of 19. And so, of course, it's best that you really wait till later. Don't start as an adolescent smoking tobacco. The brain is cross-tolerant. The brain does not see these drugs differently. They see them the same because they all do the exact same thing. So this is just showing that if you expose an adolescent rat to nicotine, they're much more likely to press the lever for cocaine than if they were just given salt water. This is also true in adults, but it's not near as powerful as in adolescents. So the adolescent brain is much more susceptible to these drugs and the effects, and that means much more susceptible to becoming addicted to these substances. And this is just showing that if you give an adolescent rat Ritalin, then they're much more likely to press the lever for cocaine as an adult. So even things like Ritalin or Adderall given to kids for ADHD can prime the brain. What I think is really important is people make sure that if they're prescribing this or if people are taking it, that there is no history of trauma or abuse in the children. Because if children are experiencing some kind of trauma or abuse, they can look ADHD in the first place, but then they also have long-term potentiation. So then that can set them up for potential addiction in the long run. However, this exposure doesn't make somebody an addict. It can prime the brain. What makes the person addicted is when they make the choice to use, because that's engaging the prefrontal motor cortex saying, yes, I'm going to do this. And that's how the drug hijacks the brain and hardwires it in. So an example of exposure, one of the ways we got smoking out of airplanes is the airline hostesses, stewardesses were complaining that they were being exposed to tobacco. And if you remember, if you were around when you could smoke in airplanes, everybody had to be at the back of the plane. Well, they did this one study where they had everybody that was sitting in the front of the plane who was not a tobacco user, they peed in a cup and had a urine drug screen at the beginning of the flight and at the end of the flight. And those people up at the front of the plane who were not tobacco users had enough nicotine in their urine as if they had smoked 3 cigarettes. And so that was how we could get it out of closed environments, because if you're exposed to smoke, even if you're not the one doing it, it is in your brain. And so I've worked with many children and many, well, mostly adults that are in treatment for substance abuse problems. And I ask them about tobacco, and I frequently get this story of, Yes, I don't know why I smoked, because I hated the fact that my parents smoked. I was taking their cigarettes and throwing them away and breaking them up. But then I started smoking, and I said, well, why did you start smoking? Well, it was because when they were 13 and adolescents, it was a peer pressure thing. So they actually made a choice to use, even though they never wanted to. But because of that choice and the fact that their brain was already primed, they got addicted from that cigarette. And then it hijacked their brain. So the adolescent period is a very important period of development, and there's a lot of things happening in the brain that are normal. This is a normal part of the time when you're learning a lot. So you're learning, you're doing go, 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 do, learn, learn, learn. And there are lots of stimulatory neurons happening. So there's a lot of dopaminergic neurons, glutaminergic neurons, and there's a lot of myelination trying to strengthen these neurons. And there's actually decreased serotonin and GABA, which are the inhibitory neurons. This is normal development, but this is why a lot of kids go through periods of anxiety and depression during adolescence. This can be very normal because of decreased serotonin and GABA. Now, like I said, the last part of the brain to develop is the prefrontal motor cortex, and that's where most of the serotonergic neurons are. And so we, as I said, think it's really in the mid-20s when it's fully developed. There's a lot of factors that can contribute to addiction when people start using as adolescents. And this has to do with the neurobiological fact that there's a lot of go, go, go. So you're stepping on the gas constantly. Very little ability to put on the brake, which is this prefrontal motor cortex with the serotonergic neurons. Decrease in parental monitoring, which is what you want. And then increased peer affiliation. And I think that's where people have to pay a lot of attention. It's better to be hanging around kids that are really into natural highs as opposed to trying something addictive. And there's certain other chemicals in the brain that we have to pay attention to. There is a receptor in your brain called the nicotinic cholinergic receptor. Acetylcholine is an important chemical in terms of thinking, processing, memory. And that's why if you know anybody who has Alzheimer's, they're usually put on drugs that are called acetylcholine esterase inhibitors, meaning they want to keep as much acetylcholine around as possible. So acetylcholine is a very important chemical in your brain for learning and remembering. It's called nicotinic just because nicotinic works on it. It's not because we're supposed to smoke tobacco. In fact, nicotine does bad things to this receptor, especially during adolescence. And if you'll notice, these nicotinic receptors are all in the reward pathway. So nicotine can actually play a role during adolescence in damaging developing brains, as the same way with cannabis. So we have CB1 or cannabis receptors all over the brain. I want a little diversion here to explain, we didn't really know why people liked cannabis until the 1960s. In the 1960s, there was a lab in Israel that discovered THC was the active component that people were looking into, that they liked. Because what they did was they were looking at all the cannabinoids and they were injecting them into rhesus monkeys, and they found that when they injected THC into rhesus monkeys, they were chill and calm and sedate. So they discovered that there was a receptor in the brain that this fit exactly into. And they called it a cannabis receptor, which is really sad because that has made everybody believe that we have receptors in our brain that mean we're supposed to smoke cannabis, and that's absolutely not true. This same lab discovered in the 1990s why we have that receptor. So they discovered chemicals that we create in our brain, and one of them they named anandamide, which is a Sanskrit word for supreme joy. Anandamide looks exactly like THC. So the THC mimics what our own natural brain makes. This is a very important receptor because this plays a big role in stabilization. So this is a homeostatic system which balances us. So it balances excitatory and inhibitory neuron activity, and it plays a big role during adolescent brain development. So our brain, when we need anandamides, it creates the anandamides immediately, produces them locally, they're used locally, and then they're destroyed. THC is a fat-soluble vitamin. Yeah, well, it could be called vitamin. It's a fat-soluble molecule that fits in that receptor and doesn't move because it stays there a long time, which inhibits the natural brain chemical from working. And this is important because during adolescence, there is a lot of things happening, and both the nicotinic cholinergic receptor and the CB1 receptor play a role in the brain determining what are we keeping and what are we getting rid of. So our own anandamides make this determination, and they will be pruning. And so there is more pruning happening during adolescence. If you put an exogenous source of THC in this brain at this time, you have absolutely no idea what is happening. And so we see a lot of issues happening that would be a totally different talk from this. All right, so as long as alcohol, drug, tobacco is being used, the drug drives the use because the neural circuitry that has been hardwired together is continually firing. So the same behavior happens over and over again. And because of the suppression of neurogenesis in the hippocampus, the person has difficulty with new memory and learning. This is why I have always advocated that treatment has to be, if you have an inpatient treatment program, has to be tobacco-free. And I have worked my entire career on that, where I was the medical director for the Circle program in Pueblo for a long time and made that program tobacco-free in 2000 in order to improve outcomes. Because if somebody is stopping all other drugs, but then they're still smoking tobacco throughout their entire treatment, they're still suppressing neurogenesis in their hippocampus, and they have difficulty learning new things. So basically what has to happen is people have to stop drugs, allow the brain to heal, and start learning new things. So there's solutions, and I do always say that recovery is completely possible. First, you have to stop using the addictive drug. Then you have to give your brain a chance to heal. And what we know from neuroscience is it takes a minimum of 90 days for a stem cell in your hippocampus to grow and differentiate. So this is, and I think that's why NIDA and different organizations have supported the fact that the minimum amount of treatment somebody should get is 90 days. However, that's pretty hard to find. I mean, most people don't get 90 days of treatment, but that is what is necessary to start learning new things. Then we encourage you to promote neurogenesis with voluntary exercise. It can't be forced, it can't be stress. You can't tie somebody to a treadmill because that would be stress and that would make things worse. But somebody has to be willing to start doing an exercise program. And then we have to rewire new neurons with new memory and learning. So you have to do something different. And then you have to remember that putting that drug back in your body causes the old wiring to fire. And so that old wiring is never leaving. It will always be there. That's why somebody who's had alcohol problems, stops drinking, hasn't drank in 25 years, they can drink and immediately be right back to addictive drinking. So the things that we encourage people to do, these are ways you can rewire your brain. So most treatment programs do provide a lot of recovery education, and that's one of the things we're doing here is giving people more education. Relapse prevention is a big part of treatment, learning skills on how to deal with relapse, how to deal with cravings, how to deal with anything that might send you back. Most treatment involves some kind of cognitive behavioral therapy, because this is about changing your thinking. So putting in new thinking and behavior. Dialectical behavioral therapy is a very helpful way of doing this. That was originally developed for people with borderline personality disorder, but I think it's helpful for pretty much everybody, because it teaches you many, many skills that you can utilize. And then strategies for self-improvement and change is another cognitive behavioral treatment that we used in the treatment program that I ran, because it helps people learn more about their criminal thinking and how you can change that. Trauma work is very important, because a lot of people end up using substances to deal with trauma and to deal with issues related to things like post-traumatic stress disorder. The drugs are not the answer. I can't reinforce enough. Things like marijuana, benzodiazepines, alcohol, they all work, right? They take away the symptoms. However, they don't treat the problem. So it doesn't deal with the underlying issue. It just treats the symptoms. And what happens is people then have to keep using, and especially if they're using high potency THC, they get very addicted to it and they can't quit. And the trauma is still there. So if they stop, the symptoms come back. So they have to continue to use. There are ways of dealing with trauma that are very helpful. I think the most helpful are things like EMDR, eye movement desensitization reprocessing, or another skill that I'm involved in training some people with is called brain synchronization therapy, but it's similar to EMDR. And then people need to learn stress management techniques, because often people are using substances to deal with stress, anxiety, and there are more effective ways that are very helpful. One that I've used a lot in my career is AccuDetox. I do train people in this. It's a 5-point auricular acupuncture protocol that was developed specifically for addiction, specifically for opiate addiction, but it works for pretty much everything, and it really helps with sleep and anxiety. Then there are other meridian therapies, like I guess the one that is easiest to learn is the motion freedom technique, but there's thought field therapy, or there's TAPAS. So these are things that would take a whole nother talk to talk about. Teaching people mindfulness, meditation, yoga, Tai Chi, and then biofeedback. There's a really excellent computerized program available for from different companies, where people can learn how to control their autonomic nervous system using biofeedback. And that can be extremely helpful in learning how to manage stress. And then there are alternatives. And so I'm highlighting these because these, like the Icelandic movement, is pretty incredible. They used to have some of the highest use of alcohol, marijuana, tobacco, drugs by adolescents. And then they pursued this whole way of changing things and getting kids involved in how do you achieve the same high that you're trying to get with drugs naturally. And they have had significant reduction in problematic use of drugs in adolescents, and it's involved the entire family. So all communities are involved in this. And we have a similar thing going on here in Colorado with Natural Highs. I encourage you to look at this website, and it's in Boulder, and they're really helping kids see that you can achieve what you want doing natural highs. You don't have to go down this road where you're potentially going to get serious problems. All right, so that is my presentation. If there are any questions at all, I would be really happy to answer them.
One question was where to find treatment.
Okay, one question is where do we find treatment? And that is something especially in this COVID time, is extremely difficult. But there is treatment available. And so we actually, through an organization called SURE, can't ever remember what that stands for exactly, but it's through the health department too. Substance use something. Anyway, we have come up with a list of all the different treatment availability and how to access that. And so that's something we could post, definitely, because there is treatment available. You just have to pursue it. There are several programs around that are helpful with that. And hopefully with the COVID thing that we're going to be getting more availability to see people in person. Right now I am doing telehealth, which is difficult, but at least we have that option. Let's see, we have some other questions. You mentioned that Ritalin primes the brain of children with ADHD to be more susceptible to cocaine use in later life. Are there other prescription medications that are known to prime the brain this way? Yes, pretty much any addictive substance is going to prime the brain. So any addictive substance that works through the reward pathway, and that's going to be all of them. So many, any of the stimulants, and there's multiple ones, Vyvanse, Adderall, Concerta. So there are many stimulant drugs used. It's also true of, opiates. If people are given pain pills, opiate pain pills as children, or it's just something you have to be aware of and be concerned about, and kids need to be aware of. So benzodiazepines are another really significant one. And I actually think benzos are used way, way, way too much, and we need to use them as less as possible. They shouldn't be used longer than a month, in my opinion. Okay, another question. Is the 90-day healing period for the brain the same for children and adults? That's a really good question, and I'm not sure I know the exact answer to that. I would assume that it's true for both, because I absolutely have seen this in the treatment program that I ran in Pueblo. I actually just retired from that. So I did that for 20 years. And it was a 90-day program. And we could absolutely see the difference over that 3-month period of time, where the first month, it seemed like the brain wasn't working at all. And then the second month, people start obviously learning new things. And in the third month, things are really starting to process. And then they were always sent out to some place where they would continue with more treatment. And we actually had really good outcomes. And I think that's why it's still around, because it's a very expensive program, but the legislature has agreed to continue to support it. So that's called the Circle program. And right now it's through Crossroads. And so that is available for people who have been in treatment before and have failed. Let's see. In terms of adolescents, yeah, I think that the healing process should be about the same. Hopefully it would be a little faster, since their brain is developing so fast. But the concern is the effect of these drugs on the developing brain. And so that's why, we really want kids to make a decision not to do anything until they reach their 20s. Because, there are a lot of adults that can use these substances without problems. And the problem is using it too soon. Okay, well, I think that that's all that we have for now. And so I appreciate you looking at that survey and filling it out. And if there's anything you would really like to hear about, I'm sure we can find people that would be happy to do more education, because I do think that this is the what we need to do. We need to educate people and help them deal with this. Okay, well, thank you very much for listening and participating. And this will be recorded and available so people can watch it again, or you can share it with friends. And, perhaps people will have questions there and we can answer the questions there. All right. Thank you very much.